Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Nurin Zahirah binti Said Zadar Abidin. My matric number is 200501 and today I am going to present on the history of Boeing 787. In the early 1990s, Boeing 67 was experiencing a major downturn in sales. This causes Boeing commercial airplanes to find a replacement for the aging Boeing 767. There were two alternatives investigated. The first was a subsonic cruiser which is the same fuel economy as Boeing 67 but still capable of cruising at Mach 0.98. And the second one is an upsized version of Boeing 747. This plane is intended to be a competitor against Airbus A308. However, it did not receive good responses from the market. Boeing has focused its new development efforts towards their new super efficient airplane product called as Boeing 787. In the late 2003, Boeing has decided to add new member to the 787 Dreamliner family with better performances airplane. On 27 January 2005, Boeing officially changed the name of 787 airplanes to 787. So next we're going to look at the Boeing 787 timeline. In the 2002, Boeing drops its sonic cruiser concept, responding to airlines' calls for better fuel efficiency rather than extra speed. In 2003, the company dubs its new carbon composite airplane, which is called the Dreamliner. Boeing approves an initial version of the plane with the temporary name of 787, the E standing for efficiency. Boeing officially launches the plane as Japan's All Nippon Airways orders 50 in 2004. In 2005, Boeing changes the 787 names to 787. Next, in 2007, Boeing starts to put together the first 787 in Everett, Washington. Boeing puts back its first test flight by about 3 months because of a shortage of bolts and problems with flight control software. And lastly, in 2008, Boeing announces third major delay due to continuing problems with unfinished work from suppliers. It sets the first test about 15 months behind the original schedule. So that's all from me. Thank you.
Hi, I am Afiqah. My matrix number is 20826.
Okay, as of now, I will explain about the common core system. So, common core system has so many functions. The first function is that it acts as the center of the airplane computer networks and other interfacing system. Second, it also acts as a technology and hardware that have been repackaged into one integrated system. Common core system has so many benefits. It benefits in so many ways in such a way of common data network, common computing resource, and the remote data concentrators. In common data network, it benefits the airplane by eliminating multiple standards and protocols. It also acts as a fiber optic network media. In computing resource, it is based on the open system architecture principles. In the remote data concentrators, it benefits in a way that it reduces the airplane wiring or weight. It also is of system upgrade and modification. It is also highly reliable. Common core system is actually a debate of an architecture approach because it actually enables saving in the cost of change down the road. The figure shows one of the airlines that have been sold the advantage of the 787, which is the Virgin Atlantic, which enable infrastructure to improve the maintenance and the flight operations. Now for the operation of the Common Core System. The Common Core System developed by the GE on the Wind River VX Works 653 partition operating environment. It is used in more than 1 billion real-time systems. It is used in more than 1 billion real-time systems around the globe. VxWorks is a real-time operating system RTOS from small consumer products to commercial airliners. GE Common Core System use a free-scale platform, and Wind River is a wholly owned subsidiary of Intel. In between 2.5 to 3 feet across and about 15 inches deep are the CCS unit, which use forced air cooling. There are 2 cabinets on the airplane. Each of the cabinet has dual power supplies and redundant processors. Literally everything is redundant, including the network.
Trust is one of the working principles which contributes by the engine. Boeing 787 use variable frequency starter generator (VFST) system where it can be replacement of the heritage bleed air system. Besides, other benefits of VFST is it eliminates the energy loss of the bleed air system pre-cooler, eliminates the throttling losses of bleed air provided from discrete engine compression stages, and etc. The main electrical power and start system of Boeing 787 is a 4-channel variable frequency system with 2 VFST where both have 250 kV ampere on each of the two main engines. The generator is a 6-pole machine with an aluminum housing driven directly from the main engine gearbox. The generator is brushless, 3-phase, alternating current and variable frequency synchronous machine. The power distribution between VFST were managed by the Bus Power Control Unit BPCU, where it performs several functions, which one of it is to control bus configuration and engine health monitoring. The electric start system offers maximum flexibility from a variety of power sources, for example, APU generators, external power cord, and cross-engine. The VFST provides full maintenance diagnostic for both entire system and all LRUs.
Hi, my name is Hasya Sufiah Danisyah binti Omar Dani with my matrix number of 202793, and this is my video presentation on avionics in civilian aircraft Boeing 787.
The Boeing 787 is a wide-body jet airliner manufactured by Boeing Commercial Airplanes. The first flight of Boeing 787 was on December 15, 2009. That was 11 years ago.
Boeing 787 is not only an exclusive and special jet airliner for the passengers.
This is because of the avionics that is in the Boeing 787 itself. Now, let's look into the avionics application in Boeing 787. One of it is for the advanced flight deck technologies.
The first one that I'm going to talk about is the EFB. EFB stands for Electronic Flight Bag.
EFB, or the Electronic Flight Bag, is an electronic information management device helps flight crew perform flight management tasks more easily and efficiently with less paper. The EFB applications include performance, e-documents, charts, taxi positional awareness, airport moving map, video surveillance of the aircraft.
Now the EFB performance consists of preloaded data, which is in the EFB itself,
and pilot entered data. The preloaded data include airport characteristics, simple elevation, runway data, and obstacle data. Next is airplane data. For example, the tail number of the aircraft, engine type and rating, and flap configuration. As the pilot entered data, the pilot will enter information about current runway conditions, current environmental conditions, which includes the weather, temperature. The pilot will also enter data into the EFB, specific airplane configuration, which is the flap position and airplane status. And there's also deferred maintenance list that affects performance of the aircraft. On the EFB, there's also e-documents. E-documents allows flight crew members to view such current electronic document on the flight deck.
another avionics application on the Boeing 787 is the large MFD, or the large multifunction display MFD.
So, multifunction displays, or MFD, presents information from a variety of aircraft information systems.
So in Boeing 787, on the flight deck, they have 5 MFDs, measures 15 inches diagonally.
Which you can see in the picture right here.
Larger MFD, there is more flexibility for the pilot to display the layouts according to their needs during each phase of flight.
MFD also serves as the backup or the fail down for the PFD, the primary flight display.
So if anything goes wrong with the PFD, the MFD will back it up.
And that is it for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alya Irdina binti Zamakshari. My matric number is 200717. Today, I am going to present about the topic of avionics in civilian aircraft Boeing 787. My contribution in this topic is the application of avionics in Boeing 787. So, next, the first application of avionics in this flight is head-up displays HUD. Basically, this flight is using this head-up displays HUD. The function of this HUD is able to project an image and data into a glass combiner mounted in front of the pilot's eyes. So it is basically can help the pilots to see the flight information, to scan for traffic or flying and approach, and the function of this HUD also can help the pilot to look outside the flight deck and at the same time can view primary flight instruments. So this HUD have give many benefits to the pilots and to the flights because it is increase the safety in all phases of flight in good or in poor visibility. So the second application of avionics in Boeing 787 is gyroscopic sensor. So basically, this flight have multiple sensors around it to help the flight to fly in a good condition. So basically, this gyroscopic sensor help to counter turbulence that caused by the variations in the wind speed. Boeing 787 has utilized a number of sensors around the aircraft. So, the function of this gyroscopic sensor to detect and measure changes in air pressure and in angular velocity, while the function of accelerometer in gyroscopic sensor to record the vertical movement. So, the aircraft is also able to detect the changes in air pressure with the help of this sensor. This sensor also able to record lateral gusts of turbulence causing wind and able to detect the changes in air pressure. So all of this information that have been obtained by this sensor is sent to central processing computers which can calculate what is happening to the aircraft but are also able to do what needs to be done to counteract these movements. So with the help of this sensor, it can ensure the safety and the comfortableness of the passengers and the pilots and the crew on the aircraft. So that's all from me. Thank you.